Hello, in this tutorial I will show you how to run Gaussian calculation. For that we will first start with drawing the geometry using Molden, then we will define what we want to compute using Vim text editor, and then we will submit the calculation for Gaussian. So let's get started. Let's start Molden. I will first draw the molecule of ethane. It's the same molecule which I have described how to draw it in last tutorial, so just quickly I take one carbon atom, then I will add second carbon atom. I will substitute this fragment by metal group. It seems a bit weird, so I will try to play with dihedral angle to look more better. Now it looks good, so the next carbon, substitute by fragment, CH3. We can see that automatically Molden did anti-periplanar configuration in this case, conformation. So I will just name the molecule as ethane C1. I clicked on the Gaussian format, I write the Z matrix. Next I want to try a different geometry, so I will just look which hydrogen of this metal group is linked to the tail. Oh, it's the other one. Okay, so I will just change it everything. So I will change this one from 120 to 60. 60, not 600. This one I will change from 240 to 180. It's relative, so I can leave it at 240, and I will just rotate the last one. And this one I will change to 120. Oh, move this one once more. Okay, so by changing the dihedral angles, I have switched the conformation from anti-periplanar to syn-periplanar. I will submit this structure as ethane C2, and now I will just find the hydrogen which defines this hydrogen, which is linked to the metal group in behind, and I will rotate it by 5 degrees. Now all the other hydrogens, the dihedral angle is linked to this one, so they changed too, and now it's almost syn-periplanar, but it's not completely. You see that they do not overlap exactly. And I will name this conformation as ethane C3 and see what happens when I will run these three structures as initial geometries for our calculation. Now I'm ready, so I can close Molden, just list the folders. Here I see that I have three structures, so I will open the first one and I will include the header so I can compute it in Gaussian. So what I need in header, I need to insert few lines. Inserting you in Vim, you insert by small letter I. So first what you need to define is a checkpoint file name, and the checkpoint file will be ethane C1 check. For instance, it's up to you how you name your checkpoint file. Just it's nice that it makes some sense that it's linked to the calculation name, and also don't mess up the checkpoint files for different calculation, because otherwise they start to overwrite each other, and that's definitely not nice. Next you need to define memory, so let's say that we want to use 10 gigabytes, why not? And number of processors, let's take 8 processors so it calculates fast. Then you need to define the header of the calculation, and there you define what you actually want to do. So let's say that I like p3lib and I would like to use 631G basis set for my calculation. What I want to do is to optimize the structure and then run a frequency calculation afterwards. these are the keywords. You can find them online on a Gaussian web page, and there are some minor changes between Gaussian version, but more or less the things which worked in Gaussian 3 will work in Gaussian 9 and Gaussian 16, and vice versa. Next, what you need to define is charge. Our E10 is not charge, and multiplicity. Our multiplicity will be 1 because it's singlet. So that's it. We can write our E10C1. See that it has been written, that we have the header. And now let's continue on the other. So now I've opened the other file. I will just copy the header, and here I will rewrite 1 to 2, once more, comma, write, enter. I have written the C2, and I can open the C3, same routine. Write, quit, write, quit. Okay, so I have C1, C2, C3. I have defined what I want to compute. Now it's time to submit the calculations and hope for the best, which means that I did not do a typo when I was writing it. So let's start with C1. And now what I'm doing is that I wrote Gaussian 16 to define that I want to submit a job. I wrote the job name, and this defines the queue. It's server specific. Usually you don't directly compute on the server where you are making the jobs and submitting the jobs, but you just send it to some queue and then it's distributed across the cluster. So here I'm just saying that it goes to the queue 83, which is the queue on our cluster. So this one is submitted, this one is submitted, this one is submitted. Okay, that's good. Now the calculations are running. Just I will run qstat to check on it. I see, I will clear it and run the qstat again. I see that my calculations are running, so we can just wait how they will finish up, and in next session I will show you how to interpret the results which we have obtained from the calculations and how to look at them both in Molden in a visual from the visual point of view, and in Vim to just check some things which are not easy to find or easy to check in Molden. So that's it for now. I hope that you like this video, and thanks for watching.